Welcome, y'all. We're jumping straight into it today. I have Camp Apex set up. It's already connected to my Trailhead org, and I'm looking at the very first challenge in our Advent of Salesforce Development. And that challenge is day 1, average number of gingerbread houses. Now, I'm not going to read this backstory to y'all, so feel free to pause the video and read it on your own to bring yourself up to speed. I'm going to start right here with our input. Real quick though, I wanted to share the goal for this video. The goal is to show you how I would work through this problem. I'll talk about some of the things I would consider first, my approach, and some general technical thoughts along the way. There might be more than one way to solve this problem, so if your solution, or even if your thought process, looks or feels different than mine, I want to emphasize that that's okay. There's more than one way to solve this problem probably, and many others here in the Advent. So I'll start off by sharing a general framework I have that I follow when I tackle these types of problems. The very first thing I do is try to make sure I understand the example that's provided and try to solve the problem by hand first. If I can't solve it by hand, there's no way I'd be able to solve it with code. Code is just a means to an end to automate our solutions. We need a solution first. So let's think about the input that was provided in that problem. They gave us a list of integers. That list was 5, 10, 3, 7, and 8. And really what they're asking us to do at the end of the day is to find the average of this list. So that's our goal for this problem. Our objective is to find the average. We know there's a really simple formula to find the average. Average is nothing more than the sum of a set of numbers divided by the count of those numbers, so how many numbers there are. Now, count is actually the easy part here. We know that the count is always going to be the same as the size of this array. I know that there's 1, 2, 3, 4, 5 elements in this list, so I know my count. I know I have to find the sum and divide that by 5 for this particular example. So what we're doing so far is step 1 of this framework that I have for solving these problems. Step 1 is solve by hand. Simple as that. Don't solve it with code, try to solve it by hand. So we've started this, right? We know half of our solution so far. What we need to do is this part, figure out the sum. Okay, so let's just see how I would do this by hand. Before I even look at this list, I know my sum is 0. What I do is look at the first index and I see, okay, that's 5. So I do 0 plus 5, and that's my new sum. Then I go and look at the very next index and I see 10. So I know sum is now equal to what the sum used to be, which was 5, plus 10. So my sum is now 15. Then I do that again, go to the very next one. I see 3, so I know I need to do 15 plus 3, and that's my new sum. So now I got 18. Again, one more time, almost there, 7. So I know my sum is now 18 plus 7. If my math is mathin', should be 25. And very last one here with 8. So last step, my sum is 25 plus 8. Should give me 33. So what I can do now is plug that in there. So I know my average is 33 divided by 5, which should get me about 6.6. And that coincides with how the example here worked. It added up all those numbers, it got 33, divided that by 5, gave me 6.6. What I need to do next here is think about the edge cases. Now, looking at the example that we were provided, these are all integers, which we would expect because it's a list of integers, but they're all positive numbers. There's no negative numbers, there's no zeros. Okay, let's keep that in mind. So we might need a solution that can handle 0 or negative values, potentially. Another common edge case that we should always consider is what happens if these values came in blank or null. So for example, I was given a list that was just completely empty. Well, if it was completely empty, according to the challenge, they told us to just return 0 whenever it's blank. Oh, but looks like they gave us a bonus one too. They thought of another edge case for us. They said, also return 0 if that list is null. That's super helpful that it gave us some of those to consider. Let's say we're just given null input. So really, if we were given a null input, even in this example, let's do another one where we're just given null, That's easy. We don't have to, there's no list for us to look through, so we just simply return 0. So maybe when we write out our solution, that could be one of the very first things that we do is check for null or check for an empty list and just return 0, right? Maybe that could be an if statement later. And otherwise, we can actually do our logic to find sum. And given that this is just basic addition here, even if this number was negative, we should still be able to add it up with these other numbers and not run into any problem. Step 3, very last thing we want to do is ensure you understand inputs and outputs. This is one of the big gotchas with this problem. If you see, the tricky thing about this problem is that it expects a decimal to be returned, but you're given a list of integers. Now you're thinking, okay, what's the big deal? Well, with Apex, the division operator returns a whole number if both the numbers being divided are also whole numbers. Let me show you what I mean. If I went to the developer console and I just did a simple system.debug and I divided 2 by 2, I should get 1. That's fine. That's expected. If I ran another test where I divided, let's say 1 divided by 2, I'm expecting to get a half. Let's see if that happens. No, I get 0. It looks like it rounded it down. And again, if I do something else like 5 divided by 2, I should get 2.5, but let's see what I get. Nope, I get 2. It rounds it down. The only way to have it actually return a decimal when you're doing this division is that one of the values being undergoing the operation, I should say, is a decimal itself. So let me instead do 5.0 divided by 2. Okay, interesting. So that's something we'll need to account for in our solution, but for now, I'll just have it in the back of my mind. Other than that, I think we have everything covered and we can give this a go to actually solve this problem. Referring back to our notes, the very first thing I did was kind of have this concept of a sum. So I'll create a new decimal called sum. Referring back to our notes, the very first thing I did was have this concept of a sum. So I want to do the same thing in my code. I'll have an integer, I'll call it sum, and before anything even happens, I'll set it to 0. Now, I want to do some defensive programming here. So the very first thing I want to do is consider some of those edge cases before I even start calculating this sum. So what I'll do here is look at street house counts, put an if condition. If street house counts is null, which was the edge case they wanted us to take care of here, or if it's empty, I want to return the sum as it is, which is 0. Alternatively, I could also just return 0 here and move this if statement up even higher. That's totally valid if you wanted to do that as well. I'll just keep it like this for now. So let me comment this out for a second and let me run my test and see how I did. Of course, I need to return a decimal. Let me do 0.0. And of course, this wouldn't work, obviously. So let me return. All right, let's see how I did. Scenario 7, what passed? Negative test, calculate average for an empty village, should return 0. Cool. Calculate average for a null input, should return 0. Cool. So I took care of these edge cases. I'm pretty set there. What I can do now is I know that if the code passes this point, that the list is neither null nor empty. So I actually do have a sum to calculate. I can't just return 0. So for that, I'll redeclare my variable here, sum. I'll set that equal to 0. And what I need is to incrementally step through this list. And we know the best tool for that is a for loop. So I'll start declaring my for loop. That'll be of the type integer. We'll call this element, call this house count under street house counts. What I want to do is the same thing I did in my notes. I'll take the sum and I'll set that equal to the house count. But that's not exactly going to work, right? Because if I come in here, let's just imagine that array again. 5, 10, 3, 7, 8. That's just going to replace my sum with whatever element I'm currently looking at. I want to keep a running total. So to do that, I'll need to take the sum and set it equal to itself plus the house count. So in this first iteration of the for loop, the sum was going to start out as 0. And I'm going to add 0 plus 5. And then I'm going to go through the for loop again. I'm going to do 5 plus 10, giving me 15 as the new sum. Then I'll go to the next element. I'll get 15. I'll add 3 to it, get my 18, and then keep going from there. Once I'm done with this for loop, I know I'm at the end of the list. So I can really just run my formula to find the average, which was the sum divided by the count. So I'll just return the sum divided by the street house counts dot size. And now that I have that, I can get rid of this return statement. And let's see how we did. Okay, we got a lot of scenarios passing, but a few failed. Let's see what those are. Calculate the average for the example village should return 6.6. So that very first example failed. Let's see why. It expected 6.6, but it looks like it rounded down again to 6. Let's see how it happened here. It expected 3.5, but it actually got returned 3. Now this is the same problem that we saw in the developer console, right? There's two ways to solve this. We can either cast this return value to a decimal, and that should take care of things. Or, better yet, maybe this sum in the first place should have never been an integer. Let's just make it a decimal. That way I don't need to cast, and I can still run my test, and they all pass. That's it for this problem. So what we did is we came up with a framework for solving this by hand. We thought about those edge cases and actually tackled those first, and then we made sure we understood the inputs and the outputs and thought about some of the gotchas along the way. Hope that helps.